Hello my young scientists. So far we have learnt how various indicators may be used to distinguish between acids and bases. So now let's see how acids and bases react with each other. We will use our previous knowledge for this. So let's start. I have some dilute HCl here. So let me take some dilute HCl, and now you remember the color change that dilute HCl gives with methyl orange. So this is methyl orange. Okay. Let me put one drop of methyl orange, and do we have a color change? We will see this against a white background. Can you see this, the color change? So from orange to pinkish red. Okay. Let us see how the color changes if I add some sodium hydroxide to it. Do you expect a color change? So taking some sodium hydroxide and putting it in this, let's see, compare the colors. So this was the color with acid, and now when I have added some sodium hydroxide, the color has changed to yellow. This is neutralization. The HCl and sodium hydroxide have reacted with each other and give us a neutralization reaction. Now let us do another thing. Let us take some sodium hydroxide solution. So this is sodium hydroxide, and now I will put some colorless indicator phenolphthalein to it, just a one drop. And what are we expecting? Are we expecting a color change? Yes. So we have got a magenta pink color when phenolphthalein was added to sodium hydroxide. If I add some acid to this, sodium hydroxide the base, phenolphthalein the colorless indicator gave us this pink color. Now if I add some acid to this, I have to see what happens. Do you see that the color is decreasing, diminishing? Wow! Slowly, as acid and base react with each other, that means they neutralize each other, the color disappears, because now the amount of acid in this test tube is more than the amount of base. So all the base has reacted with the acid and the color has disappeared. So my dear young scientist, the base in this particular case sodium hydroxide and acid HCl reacted with each other to give sodium chloride, the salt, and water. This reaction between any base and any acid to give a salt and water is known as neutralization reaction, and in general you can write this reaction as base plus acid gives salt and water. You may even write now the reactions for various acids and bases to give salt and water. So my young scientists, after understanding how acids and base react with each other to give salt and water, let's see how an acid or a base react with a metal. So I have some zinc metal with myself. So let me pick one zinc metal piece, and this is a U tube, okay, a special tube, and I am putting one piece of zinc metal in this, and now I will add some dilute HCl to this. My dear scientists, this activity is to be done in the presence of the teacher, or it can also be as a demonstration activity with your teacher. Only adult guidance you have to do this. Okay. So now I am putting some dilute HCl to this, and on this end of the U I will put some soap solution. So this is some soap solution that I have with myself. So I will put some soap solution this side in the arm of the U tube. Okay. And let us now see that the reaction occurs. Okay. When the reaction occurs, now you can see the bubbles are rising. The bubbles are rising here. Can you see this? The reaction is occurring, and if I touch this, this is also becoming a little warm. Can you tell me from your previous knowledge of chapter 1 that if the test tube becomes warm, this is an indication that a reaction is occurring, and also because the bubbles are rising, this is also an indication that a reaction is occurring. So, reaction is occurring, but what is the reaction? What is happening? This bubble is rising, and now let us test these bubbles with the burning candle. Okay. So, did you hear that pop sound? Yes. This means that this gas, which is a colorless gas, is hydrogen gas. Why should you agree to what I said? If I say it is the hydrogen gas that is evolving, a scientist always has to question. You have to question me that how do you say, ma'am, that this is hydrogen gas? Then I will tell you that the gas is colorless, you can't see any color, and because this gas is burning with a pop sound, it is the property of hydrogen gas. So, my dear friends, we will say that acids react with metal to produce hydrogen gas, which burns with a pop sound, and what is the next product? It is salt. So, let us write a reaction. Acid plus metal gives salt plus hydrogen gas. And if I do this in terms of HCl, let us write this, HCl and zinc, it will give us a salt, and the salt would be zinc chloride and the hydrogen gas. Similarly, you can write reactions for dilute sulfuric acid, dilute nitric acid, etc. Now, after seeing that how acids and metal react, I wish to check whether bases also react with metals in the same manner. So, let us take another U-tube, a clean one, and pick up another piece of zinc metal. Can you see that I am not using my hands, my fingers to pick up the pieces? So, I am picking forceps. All this is very important for scientists, okay, to observe the precautions. And now, I will put some sodium hydroxide. Again, I would say that this reaction has to be done in the presence of adult guidance. Sodium hydroxide solution has to be prepared a little concentrated, and now when I put it in this, a little warming is required. Before that, I will put some soap solution again. Okay. So, I have here zinc metal, concentrated sodium hydroxide solution and soap solution in the arm. We will warm it a little because the reaction is a bit slow. Okay. So, after warming, now you can see that the gas bubbles are rising. We will check these gas bubbles too. Do these gas bubbles also burn with a pop sound? Yeah, you heard that? The pop sound. So, whether acid or a base, both react with metal to give salt plus hydrogen gas. Let us see the next reaction. So, the reaction taking place in this test tube is sodium hydroxide dilute plus zinc gives sodium zincate, which is the salt, and hydrogen gas. I will repeat again, the solution of sodium hydroxide is dilute. When I said that you have to prepare it a little concentrated, that means you have to add 2 pallets of sodium hydroxide to produce 10 ml of sodium hydroxide solution. So, let us see how does a base react with metal. So, now we have added a metal piece, that is zinc, to the U-tube and some sodium hydroxide solution. In the U arm, we have added a soap solution. So, we have seen how zinc metal, which is a reactive metal, reacts with base sodium hydroxide and acid dilute HCl. You have to check with other metals too. Make a table and see whether all metals react in the same manner with acid and base. That is for you to check. So, young scientists, we have learned how acids and bases react with each other. We have also seen the reaction of acids and bases with zinc metal. Now, let us see how metal carbonates and metal hydrogen carbonates react with acids. So, I have some sodium carbonate and sodium hydrogen carbonate with me, and we will see the reaction of these. So, again I have my U-tube, and in this U-tube I will put some sodium carbonate in the test tube, let us put some lime water in the arm of the U. Okay, yes, there goes the lime water. And now let us put some dilute HCl. So, can you see these brisk effervescence rising, and the lime water in the arm of the U tube is turning milky, and the bubbles that are rising, these are the bubbles of carbon dioxide. And as the amount of carbon dioxide that passes through increases, slowly the color of lime water again turns colorless. Can you see that? The milkiness is disappearing. Let us repeat the same experiment with sodium hydrogen carbonate and HCl. Yes, it also gives us brisk effervescence, and yes, again lime water is turning milky, and the milkiness disappears with passing of excess of lime water. So, let us see the reactions involved in this beautiful activity that we performed. So, sodium carbonate we took solid, so let us write that Na2CO3 solid plus HCl that was aqueous gives salt, that is NaCl, water and carbon dioxide. This carbon dioxide was tested by passing it through lime water. That is the property of carbon dioxide, that it turns lime water milky, and the milkiness disappears when excess of carbon dioxide passes. Similarly, sodium bicarbonate reacts with HCl to give again the salt NaCl plus water and carbon dioxide. You can balance the reaction yourself. So, now there is quiz time. You have to write a reaction when magnesium carbonate react with hydrochloric acid, and also when magnesium hydrogen carbonate react with hydrochloric acid. These two reactions you will write. You may also try the reaction instead of HCl with H2SO4, what salt we will get, and again the product is going to be water and carbon dioxide with the salt. So, my young scientists, we have learned now the neutralization reaction, that is the reaction between acids and bases to give salt and water, the reaction between acids and metal. We also have learned how metal carbonates and metal hydrogen carbonates react with acid to produce carbon dioxide. I am sure now that you will be able to write balanced chemical reactions for all the reactions that we performed. You can also plan an experiment if some unknown liquid is given to you, so that to identify whether it is an acid or a base. My dear friends, you have to remember to keep your surroundings clean and take care of the environment. So, when you are using your chemicals, please do not throw them just like that, and also use minimum amount of chemicals while performing the activities. So, my young scientists, now let us see how acids react with metallic oxides, or how metallic oxides react with acids. But I have a problem. I do not have a sample of metallic oxide in my lab. So, what do you say? Should I just accept what is written in the books and stop experimenting, or can you suggest me some idea? Yes, I know some of you must be thinking about the reaction that you studied in chapter 1, that is magnesium reacts with oxygen to form magnesium oxide, and magnesium is a metal. So, magnesium oxide is a metallic oxide, and this reaction is known as, can you tell me? Yes, combination reaction. It is a combination reaction that we studied in chapter 1. So, we do not have to forget what we studied previously. We have to build up our knowledge on this. This is also a attribute of a good scientist. Okay? So, let us start. We have this magnesium ribbon, okay? And the magnesium ribbon has got a black layer, which is a magnesium oxide layer. If I have to do the experiment, first of all I have to clean it so that I get a shiny surface. So, I am rubbing it with a sandpaper so that I get a clean shiny surface of magnesium. Magnesium is a very reactive metal. So, it gets a black coloration of oxide layer. So, now here you can see it is a shining magnesium metal piece that I have, and we will burn it in oxygen, burn it with candle. Okay. Right now I have a candle with me. You can use a Bunsen burner if you are doing it in the lab or a spirit lamp. The experimentation, my dear friends, should never be stopped. Okay. And where will I keep it? Which part of the flame is the hottest? Yes, it is the topmost part of the flame. So, I have to keep my magnesium ribbon at the topmost part of the candle flame, so that because it is the hottest zone, again connecting with the previous knowledge, isn't it? So, now you see what a beautiful white dazzling flame. My dear friends, when you are performing this experiment, remember not to look directly into the flame of magnesium, because the flame is so dazzling white that it may harm your eyes. Now, you see, after burning we have got magnesium oxide, the ash. We have collected this in the china dish, and now to this I will add some water to make a solution. Okay. So, we add some water here, and to this I add a drop of phenolphthalein. By now we all know that phenolphthalein is a basic indicator, and it gives me a pink coloration when it reacts with bases. So, see what a beautiful pink color we have got. I will transfer this to a test tube so that you can see the experiment easily. Okay. So, we will transfer this into the test tube. Yes. Now, you can see this pink colored solution, which is due to the reaction between the metallic oxide, that is magnesium oxide, and phenolphthalein, the indicator. So, beautiful light pink color. So, we had dissolved magnesium oxide in water, which gives me magnesium hydroxide. This with phenolphthalein gave me pink color, and now let me add some dilute HCl to it to see how metallic oxides react with acids. By now you already know what is going to happen. It is no more a magic for you, I am sure, because when we put this acid, the color should disappear. Wow. Okay. So, the pink color that we had between phenolphthalein and metallic oxide has got disappeared when we added some acid. So, the reaction is similar to what we did between bases and acids. Here also a metallic oxide, because it is basic in nature, will give us a salt and water when metallic oxide reacts with acid. So, we can see the reaction is similar, because metallic oxide when dissolves in water give us a metal hydroxide. So, the reaction can be written in the same manner: metal oxide plus acid gives salt and water, that is neutralization. Now, we need to see how non-metallic oxides react with bases. Now, where to get a non-metallic oxide? Scratch your brains. What happens when we breathe out? Which gas do you breathe out? Carbon dioxide? Yes. And what type of element is carbon? It is a non-metal, isn't it? So, carbon dioxide is a non-metallic oxide. We have to just check the reaction of this non-metallic oxide, that is the carbon dioxide, with the bases. Let us do this experimentation, a very quick and easy one. So, let us get started. Here I have the NaOH solution. Let us take it in the test tube. And a drop of phenolphthalein, because my reaction is that how do base react with non-metallic oxide, or I can say how do non-metallic oxides react with bases. So, I have taken a base and an indicator which will tell me whether the reaction has taken place or not. Okay. So, base and phenolphthalein, the indicator, and the non-metallic oxide is the carbon dioxide that I am going to blow into this. And let us see whether something happens, whether color changes or not, you have to see. Okay. So, blowing in carbon dioxide. While blowing in, you have to remember that you do not have to suck it in, otherwise all this material will go in. So, you have to be very careful. Okay. Take a deep breath and again. Beautiful. The pink color has got decolorized. That means a base reacts with a non-metallic oxide to again give us a neutralization reaction. So, we can write a non-metallic oxide plus a base again gives me salt and water. Can we write it for the same reaction? So, carbon dioxide was passed into sodium hydroxide, and what would be the salt? Yes, it is sodium carbonate and water that was produced. Okay. So, that is why the color got changed. Now, again you can do some other activity also which we performed just now. Can you tell me? This is a quiz time. How to test that non-metallic oxide reacts with the base? You can do lime water test, isn't it? You can try it yourself. Again remember, while blowing in carbon dioxide, you do not have to suck it in. Okay, so my dear young scientists, too many properties of acids and bases you have learned. I wish to know whether you are able to connect these properties with our day-to-day life observations, because that is the best attribute of a scientist. You know, when I was young, of your age, my mom used to tell me that don't put curd in the iron utensil, do not put lemon in that brass tumbler. That time I didn't question much. I asked my mom, but she didn't have much answer. She said because her mother used to tell her like that, so I also have to follow. But a scientist have to ask questions. Okay? And it is not only about asking questions, you have to also spend some time in finding answers to those questions. Okay? So, now I know, and you also know, pure iron utensil or a copper utensil, you should not put curd or lemon, etc., because these are acidic substances and they will react with metals. So, the quiz was, why should curd and sour substances not be kept in brass, copper or iron vessels? You have the answer now. So, my dear scientists, when my mom says that do not put curd and lemon in the iron utensil, should I just agree to what she is saying without asking question, or I should try and find an answer in the scientific manner? I am sure after going through the properties of acids and bases, you can surely give me an answer that why sour substances which are acidic in nature should not be kept in metallic vessels like that of copper or iron.